Hello again and welcome to the second part of that video regarding the change of the laser tube in a K40 laser to something really stupid. Speaking of stupid, the first thing you can see is if you followed my first video, which I will link in the right upper corner again, then you now know it's really a stupid idea to have that laser tube sitting in its box while firing it. Nothing happened so far, but after a few test shots, well, you can see the results. Another box that I want to show you, and this box is quite interesting. If I just tilt up the camera a little bit, you already can see that there's hoses going below that box, and strangely enough that box is connected to the K40 laser, which means it's very roughly hiding the laser tube that is really now installed inside the original K40 laser. Well, let's say a little bit of it is installed inside the K40. The rest just sticks out at the right hand side. I know it's stupid, but this is just for a test. So that's not the final setup for the laser. This is basically just to see if everything works as supposed. I will quickly get that cover off and show you how it looks like. So there you go. This is the new laser tube. Again, 130 watt laser tube. If you haven't seen the test video, just scroll through my videos and see what happened. And just for comparison, let me just hold that camera and quickly get the original tube out, which is laying here. And this is nice little baby tube. Sorry, didn't want to say lady tube. So that's the original one, and below is the 130 watt laser tube. So this one ends even before the new one starts to penetrate the housing. That's what I call a real tight fit. So I printed out some new holders, and you can see there's really no more space. So that's tight. Same at this end, also really tight. Yeah, but it fits. So even the position of the beam to the first laser mirror is quite okay. Not too much to worry about. So that's good. Nevertheless, as you can see with these stickers here, the masking tape, I really had to do a lot of test shots, and that's not all. I think I threw away most of the test shots, but then I started to realize it might be interesting to just stick them onto the cover and just understand how many test shots I had to do. The major problem was that the diameter of the tube is 80 millimeters instead of 50 millimeters, so the whole laser ray just lifts. So you have to compensate that by the mirror settings, because all your mirrors are now basically hit at the very top. So, but I managed to get there. So the next thing I would like to show you is the power supply for the stepper motors. So here's the power supply for the stepper motors. As you can see, I decided to run them at 12 volts, and they are connected via that cable to the original input that goes to the board. So I was surprised. These steppers just run smoothly at 12 volts. No need to run them at 24 volts, for example. Let me just show you how good they actually run. I just prepare a little program, or a homing maybe. Okay, I just put the laser head to the far outer side, and I just initialize the laser, and you will see how smooth it runs with 12 volts. There you go. So that works like a charm. So that's a piece with some test shots on it. Um, this is MDF, so that's a material that always caused me trouble with the old laser tube, because you had to go really slow, like I don't know, 6 millimeters the minute. Oh no, it's not minute, it's second, right? So 6 millimeters a second, and I don't know, 60 milliamps, which is the more or less the maximum of what I used to drive the old laser tube. And these cutouts here, I think the best one, which has the slightest burn marks, they were done at 22 millimeters a second with somewhere around 14 milliamps, which is equal to, let's say, I don't know, 60 watts maybe. I have to figure out that. But this, it just cuts through like butter. So 22 millimeters a second is really fast. Um, so no doubt, even with the old laser head and not the optimum settings, this is just burning through like nothing. I really enjoy doing the first test cuts with that. I also figured out that my 3D printed air assist is totally scrapped because it just melts away. I am already turning a good one. It will take a little bit of time until it's ready, but this has to go away. Yeah, and anything else just worked as I was hoping it does. So I'm pretty happy. Um, Next video I probably show you some cuts, um, just because it's fun to watch. So here's a little test shot. 4 millimeters MDF, speed of 20 millimeters per second at 12 milliamps, and with air assist on. So enjoy. Nice. Okay, I thought it might be helpful, um, because I was referring to the masking tape and all that test shots. Uh, I think it's helpful to quickly put up some graphics to illustrate the problem with the laser beam. This is an ideal setup, similar to what we can find in the K40 laser, and you can see I adjusted it so it's basically exactly in the center of our workpiece. And in the next image, this laser beam is just tilted up about 0.5 degrees, and have a look what happens. This is a good example of what happens. It's certainly worst case scenario, as our beam source is way closer to that first mirror. But just that you get an idea, if you have a misalignment from the beam itself, then the ray would eventually not fully hit your laser head. And that being said, you can see a deviation in the position where the laser beam hits the material, and also the losses because of rays which won't find their way to the workpiece. So that's just something that's really not as dramatic as shown here, because as I said, our laser is
quite close to that first mirror. However, you have to deal with the alignment of the laser tube, and you have to deal with the alignment of all three mirrors. Well, this one you normally can't adjust. You can just reposition the whole head a little bit, but at least this and this mirror need to be perfect, and the laser beam itself needs to be level in 3 dimensions, let's say. Okay, that's it for the moment. Thanks for watching.